Welcome back everyone on my channel. Today we will discuss geometric sequence, where each term is obtained by multiplying the previous term by a fixed number called the common ratio. Geometric sequences are found in many real-life situations such as population growth and compound interest. So let's begin solving a numerical from Pearson's Maths textbook for grades 11th and 12th to understand the concepts. Also, please watch the video till the end. Do like and share as we proceed, and also subscribe to my channel for more such interesting lessons. So let's begin. So the sum given is the fourth and the seventh term of a geometric sequence are 18 and 729 by 8 is 59049 by 128 a term of this sequence? If so, which term is it? Now first, the general formula for any geometric sequence is un is equal to u1 multiplied by r to the power n minus 1. Now here un is the nth term, u1 is the first term, r is the common ratio, and n is the number of terms. So using this formula, let's begin solving. The fourth term, u4, is equal to u1 r to the power 4 minus 1. Now substituting the values, we know that the fourth term given is 18 is equal to u1 r cube. Now here u7, also the seventh term is given. So u7 is u1 r to the power 7 minus 1. Now putting the values, the seventh term is 729 by 8, which is equal to u1 multiplied by r to the power 6. Now u1 is equal to 18 by r cube, and here u1 is equal to 729 divided by 8 multiplied by r to the power 6. Now u1 is equal to u1, so equating these two terms, we get thus 18 by r cube is equal to 729 by 8 multiplied by r to the power 6. Now cross multiplying, what do we get? 18 multiplied by 8 r to the power 6 by r cube is equal to 729. So this means r to the power 6 by r cube is r to the power 6 minus 3, which is again r to the power 3, is equal to 729 divided by 18 multiplied by 8. Now if you factorize 729, now we know that in the unit place we have the number 9. So this applies for the number 3, divisibility of number 3. So we'll divide by 3, we get 243. Yes, and then again further dividing by 3, we get 81. Then 27. 9 and then 3. So this is 3 to the power 6. Now we know that 18 is 9 multiplied by 2 and 8 is 2 cube. Now this is 3 square. Now 9 is 3 square. So I'll just write 3 square here. So simplifying, we get 3 to the power 4 by 2 to the power 4. Now this is r cube. Now from here we can find r. So r will be 3 by 2 multiplied by root under 3 by 2. So this is the value of r. Now let's solve further. Just give me a moment to erase. Now we will calculate the first term. We have found the value of r, which is 3 by 2 multiplied by root under 3 by 2. So u1, substituting the values in 18 by r cube. Okay, what do we get? So u1 will be 18. Now r cube was 3 to the power 4 by 2 to the power 4, if you recall. So this will be 18 multiplied by 2 to the power 4 by 3 to the power 4. If you simplify, you get 18 is 9 multiplied by 2 multiplied by 2 to the power 4 divided by 3 to the power 4. Now we know that 9 is 3 square. Okay, so simplifying, we get 2 to the power 5 by 3 square. So this is 32 by 9. So this is u1. Okay, now we have to find whether 59049 by 128 is a term of the sequence or not. Now again, putting these values in the general formula, let's test it. 59049 by 128 is equal to u1, which is 32 by 9, multiplied by the ratio, common ratio r, which is 3 by 2, multiplied by root under 3 by 2, whole thing to the power n minus 1. Now if you simplify 59049, now we can also cross multiply. 9 multiplied by 59049 by 128 multiplied by 32 is 3 by 2 multiplied by root under 3 by 2, whole thing to the power n minus 1. Now this is 9 multiplied by, now if you factorize 59049, let's try factorizing here. 59049. Now again, in the unit place we have number 9, so divisibility rule for 3 applies here. So if we divide by 3, what do we get? 19683. Again, dividing by 3, we get 6561. If you further divide by 3, we get 2187. And then again dividing by 3, we get 729. Now, in the previous part, we had calculated that 729 is 3 to the power 6. Okay, this is 3 to the power 6. So 3 to the power 6 multiplied by 3 into 3 into 3 into 3, we get the value of 59049 as 3 to the power 10. Now 128 is, let's try and factorize 128 here. By 2. So 2 6 are 12, 2 4s are 8, 2 32. Now we know that 32 is 2 to the power 5. Multiplied by 2, we get 2 to the power 7. Multiplied by 32 is 2 to the power 5. Now we equate this with the common ratio 3 by 2 multiplied by root under 3 by 2 to the power n minus 1. Now we know that 9 is 3 square. So 3 square multiplied by 3 to the power 10. So this will be 3 to the power 12 by 2 to the power 12, which is 3 by 2 whole to the power 12. Now let's solve further. What do we get? Okay, just give me a moment to erase. Now we had found that 3 by 2 to the power 12 is equal to common ratio 3 by 2 multiplied by root 3 by 2 to the power n minus 1. Now if you simplify this part, what do we get? Now this is 3 by 2 multiplied by 3 by 2 to the power half, n minus 1 by 2. Or we can do one thing. Now just this part is 3 to the power 1 plus, this is 3 to the power half, so 1 plus half by 2 to the power 1 plus half, whole thing to the power n minus 1. So we can write this as 3 by 2 to the power, now 1 plus half is 3 by 2. So 3 by 2 multiplied by n minus 1. Now this is equal to 3 by 2 to the power 12. Now bases are same, the bases being 3 by 2, hence the indices are equal or the powers are equal, hence 12 is equal to 3 by 2 multiplied by n minus 1. So this means n minus 1 is equal to 12 multiplied by 2 by 3 by cross multiplying. Then again we get n minus 1 is equal to, if we strike off the common part, so 3 4s are 12, so 4 multiplied by 2 is 8. So this follows n is equal to 8 plus 1, which is 9. So yes, since n is a whole number, positive whole number, so we conclude that 59049 by 128 is a term of the sequence and the term is 10th term. So yes, 59049 by 128 is the 10th term of this sequence. So today we learned that a geometric sequence is formed when each term is multiplied by the same constant value called the common ratio. Thus, we can find specific terms using the general formula un is equal to u1 multiplied by r, which is common ratio, to the power n minus 1. Understanding geometric sequences helps us solve many mathematical and real-world problems involving growth and decay. Keep practicing different examples to strengthen your understanding and build confidence in this important topic. See you in the next lesson video. Till then, happy learning!